Okay, Yusuf, you can. Yusuf, you can.
Yeah, doctor.
Yeah, now it just started. Okay, started recording. So what today we are going to study is about. You cannot record from your side, right?
No, doctor.
Yeah,
We
yeah. Okay,
can't.
okay, done, done. The recording started. So now today we are going to study two charts. First chart is control chart 4. I'm going to write here just to see the name of the chart. Control charts. The name is control chart for defectives. Defectives. So we call the chart as P chart, control chart for defectives. Second is control chart for defects. Defects is also called as C chart, control chart for defectives and control chart for defects. So these are the two charts we have, control chart for defectives and control chart for defects. Now here, as I explained before, control chart for defectives means what? Defectives means out of 100 products, say 10 are defectives. This is called P chart, control chart for defectives. Then what is the meaning of C, control chart for defects? See, take one part, there are say 5 defects in one part. Say one hotel, you are getting 10 complaints. Say one day you have 10 problems. These are control chart for defects. So each item has say how many defects. That is called control chart for defects. So you have to identify which chart it is. I will not say it is defects chart or defectives. You have to identify which type of problems. So here, as you can see in here, in the question, they are inspecting 1,500. See here, here 1,500 data are inspected. So this is the inspector name. Each inspector inspects 1,500 data, and they found that out of 1,500 data, 4 mismatched. Mismatched means like defectives. So out of 1,506 mismatched, that means like defectives. So here, uh, question is construct a suitable chart. Whenever it comes to that suitable, whether it is the X bar chart, whether R chart, whether P chart, whether C chart, you have to select which chart it is. You have to choose which chart it is from the question. So since the products are inspected and there are 4 mismatched or problems, means definitely it is going to be P chart, which is called control chart for P chart is called control chart for defectives. Control chart for defectives. Okay, defectives. That is called P chart. Now we need to prepare another column. P chart we are going to draw. Each chart will have a center line control limit, will have upper control limit, and then we will have a lower control limit. We have to calculate all of them. But before that, we have to prepare one more column here. That column represents P. What is P? P means fraction defectives. P means fraction defectives. What is fraction defective? 4 divided by 1,500. 4 by 1,500. That is how much? 4 by 1,500. So that is equal to 2.666 times 10 to the power minus 3. Do you have a calculator? So number of defectives, 4 divided by number inspected, 4 by 1,500. Next is 6 by 1,500. How much? 6 by 1,500. You have to use the calculator. You have it, right? Yeah, please use it and tell me the values from next one onwards. Can you
4
give the
times
value?
10 to the power minus 3.
Yeah, next is the same p value. P means what? Fraction defectives, ratio. What about 2? 2 by 1500.
1.3 times 10 to the power minus 3.
Yes, okay, very good. Next is 15 divided by 1500.
0.01.
0.01.
0.01. 2 fours are there by 1500.
Just like first one.
For 2.66 times 10 to the power minus 3. Correct? We have all these values. Now p values are there. You know how to get p bar. Take the average of this. If you have difficulty in this, you do one thing. You add all these defectives divided by add all the inspected numbers. For example, 4 plus 6 plus 6 plus 2 plus 15 plus 4 plus 4 divided by 1500 plus 1000. So 1500 into 2, 4, 6, 7. 1500 into 7. So how I will write? Total defectives. What are the total defectives? Say 10 plus 6, 16, 18, 33, 37, 41. Am I right? 41? Check it. Divided by 1500 into 7. This is P bar. P bar. See this, the mean, the average, or take average
Yes.
of this. It is same,
41.
right? How? Yeah, 41. How much it comes divided by? Why I wrote 1500 into 7? Because 1000 total is 1500 plus 1500 plus. So I just multiplied that. Yeah, how much is the
3.9
value?
times 10 to the power minus 3.
10 to the power
3.9
minus 3.
10 to
Very
the power
good.
3. Yes.
Very good. So we got P bar. What is P bar? The middle line, the control limit is P bar, which is 41 divided by 1500 multiplied by 7. So 3.9 times. So what is upper control limit? Upper control limit, which is, so we go for Z3 always. So P bar plus 3 sigma. Sigma must be given anywhere in the question. It is not given. So equation for sigma is given. We will write directly here instead of sigma. This is sigma. What is sigma? P bar times 1 minus P bar divided by n. Is that clear? Upper control limit. So what is P bar? 3.9 times 10 to the power minus 3. Plus 3 multiplied by square root 3 times square root of P bar. P bar is 3.9 times 10 to the power minus 3 times 1 minus P bar. You can write here, please write it, divided by n, number of samples inspected. How much average number of samples? It is 1500 samples inspected in each lot. Correct? Because it is same. So you can find upper control limit here. Can you find the value of upper control limit? Is that clear how I substituted the values? It is direct. Sigma is sigma p here. So directly you can substitute and get the values. Are you doing? Mariam, Yusuf, are you doing? Zakaria, Azam.
Yes, doctor.
Yeah,
Working.
yeah, I need upper control limit because I am directly solving the problem. Your answer will be taken.
$8.73 multiplied to 10 minus 3.
8.73
multiplied 10 to the power minus 3.
-3. I will confirm. I need answer from any one more to confirm. Okay. Second answer the same from any other person to confirm this, whether this is, we can proceed with this.
Yes, same.
Same. So now we go for lower control limit. Lower control limit, only plus will change to minus. So equation for lower control limit, if I write here, LCL is P bar minus 3 times square root of P bar times 1 minus P bar by N. Can you calculate it now? Everything same except minus at the middle.
Doctor, it will be minus, right?
Yeah, if you get minus, don't worry, tell the value.
Minus 0.066.
0.66. So let us wait another question from any other. Okay. And then we will proceed. Hope that others are doing this. To confirm it, then only we can proceed to our next step.
Doctor, I get minus 9.2.
Minus 9.2.
Same. Minus 9.2 multiplied 10 to the power minus 4.
Yes.
So please check it. 9.2 times 10 to the power minus
Minus
4.
4.
4. Okay. So once again, just check it quickly to proceed. Okay. The last check.
Yes, minus 9.1.
Yeah, then we will cross this one and we proceed. Since we get a minus sign, we take it as 0. Lower control limit becomes 0. Whenever you get minus, it becomes meaningless. That means lower control limit will be equal to 0 and upper control limit we have. Already we calculated control limit, upper control limit. Then how to draw it is, so your x-axis, the x-axis will be the sample number. Then you can draw the same axis. Sample number means how many we have. So here the second one will be a lower control limit. Or even in the same line you can represent them. Same line you can represent lower control limit because it is 0 anyway. Then middle, you can put middle or this is control limit, which is equal to P bar. Then you have an upper control limit here at the top. This is upper control limit, which is, you have the values. Let us write the value of upper control limit. 8.73 times 10 to the power minus 3. P bar is equal to 3.9 times 10 to the power minus 3. So how many samples we 1, 2, 3, 4, 5, 6, 7 samples. So I will put here sample number. Sample is the, or we here it is not sample, we can say the inspector. I can say inspector, or sample number is the basics. So inspector is the name given here. So we have how many samples? We have 7. So 1, 2, 3, 4, 5, 6, and 7. So we plotted 7 here, and y-axis will be P, or fraction defectives. What is P here? P we already calculated. For example, first sample, this is the first sample. P is 2.66 times 10 to the power minus 3. So corresponding to 1, 2.66. How to put 2.66? Where it comes? So 2.66 comes somewhere here, approximately. See, 1 we plotted, we marked 1. Now we have to mark 2. How to mark 2? 2 is 4 times 10 to the power minus 3. So 2 is 4 times 10 to the power minus 3. This is 2, which is 4 times 10 to the power minus 3. Now 3, 4 times 10 to the power minus 3 again, that is 3. 4 times, it is 3.9, sorry, 4 times 10 to the power minus 3. Then this is 1, 2, 3, sorry, 3, fourth is 1.3. So fourth is 1.3, which is somewhere here, fourth one. Then fifth is 0.01. That means 1 times 10 to the power minus 2. So 1 times 10 to the fifth is 1 times 10 to the power minus 2, means it is crossing the limit, correct? Above upper control, 0.01. Then 0.01 is 1 times 10 to the power minus 2, which is crossing the limit. Then we have 2.66 times 10 to the power minus. This is which one? I did wrong somewhere. Something. How many are there? 1, 2, 3, 4, 5, 6, 7. So 1, 2, what is 3? Yes, 1, 2, 3, 4. 4 is 1 point. Yes, 5 is 0.01. 5. Okay. What is 6? 6 is 2.66. 6 and 7. 2.66 means it has to be somewhere here. Same. 7 also same. So what you need to do? You need to join them. 1. You need to join them. So this chart is called P chart. That's it, finished. This is called P chart. So if you interpret the chart, interpret means what is the result of this? That is called interpretation. If you interpret this chart, you can see that lower control limit, upper control limit, and control. One of the point has gone out of the control limit. So we say that the process is out of control. The process is out of control because of what? Because of observation 5. So observation 5 has gone out of control. Hence, we say that the process is out of control. The process is not in control. Is that clear? If it is clear, I will proceed to next question. Any
Yes,
doubt
Doctor.
in this? Any doubt in this?
Clear, Doctor.
Clear. Then I can proceed. Even the recording is there. You can watch it later if you want to repeat. So any doubt, you can see the recording. Please save the recording also. Okay, I am going to. I'm proceeding to next question, which is control chart for defects. Only thing is, in the question, the name of the chart will not be specified, like P, C. From the question, you have to understand which chart need to be selected. That is the first step. So the question will be draw a suitable control chart. You have to see which one need to be selected, whether P, C, X, etc. As I told you, if you measure a dimension like a diameter, like length, like width, temperature, it is X bar control chart for variables, X bar and range control chart for mean and range. If you are specifying in defectives, problems, say out of 1000 X, 10 of them broken. So this is called control chart for defectives, P chart. Then defects means one item, they 4 defects, say one hotel, 10 complaints. This is called control chart for defects or C chart. So today, now we are going to discuss about C chart, which is control chart for defects. Control chart for defects. So Dave Christie runs a car wash chain scattered throughout Manitoba. He is concerned that some local managers are giving away free washes to their friends. He decided to collect data on the number of voided sale receipts. Of course, some of them are legitimate voids. So would the following data indicate a reasonable number of voids? Voids means defects or problems at his facilities. So voids means like defects or problems or whatever it is. So from the same car wash center, you are getting these defects or voids. So it is related to control chart for defects. So when he decided collect, so car wash center runs a car wash chain scattered through it. Okay, this is the place. So he is concerned that some local managers are giving away free washes to their friends. So he wants to catch his friends. He wants to catch the people who are giving this like free washes to those people. Then he decided to collect. So he has the chain and this is the place. And he found that 3, 8, 3, 4, 6, 5, 0, 1, 2, and 4. In the same in Manitoba, or this is the place from where he's checking, and he found these are the free washes given to these people from one center 3 like that. So we have to draw a suitable control chart, and it is, as I told you, it is control chart for defects. In control chart for defects, first step we have to find C bar. How to find C bar? You need to add all of them. 3 plus 8 plus 3 plus 4. How many? See, car wash chain. That means this is one area. This is a second area. This is third area. Like that. How many areas you have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 areas. So divided by 10. This is C bar. So can you calculate it and tell me how much is this value? You have to take all, add all of them and divided by 10. How much?
3.6.
3.1.
So how much?
3.6.
3.6. All same answer?
Yes.
3.6. So we got a control limit as in a C chart. Control limit is equal to C bar. We take upper control limit is equal to C bar plus 3 square root of C bar. Can you calculate it? 3.6 plus 3 multiplied by square root of 3.6. How much it will be? Similarly, lower control limit is C bar minus 3 times square root of C bar. So 3.6 minus 3 times square root of 3.6. What is the value? upper and lower control limits?
9.29.
The first one is 9.29. Second one?
Minus 2.09.
Sorry?
Minus 2.09.
So we take it as 0, correct?
Okay.
Yeah. So can you calculate and see how much? Okay, we got it, right? Now we need to draw it. We have the control limit. How do we draw it? Is we have the first one, 0 is this one, 0. Just a minute. Yes, class. Yeah. Just please hold on. Yes. Yeah. Yes. Sorry for that. Actually, I was in a meeting. Are you with me?
Yes,
Yes, Doctor.
Yes,
doctor.
doctor.
Yeah. Okay. Now what we need to do is we need to draw it. So I think you have the values. I deleted it anyway because now can you give the values of how much is C bar and the upper control
3.6.
3.6, 9 point something per
2,
control
9.
limit. And this is
9.
0 and
Yes.
9.29, correct? So we have these values. Now we need 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we will put 10 here. So a little bit, yes. 1, 2, you can put 10, 3, 4, 5, 6, 7, 8, 9, and the last one becomes 10. It is crossing this side, but we can adjust it later. Whenever you draw it, you can use a ruler, then you can adjust it. So this is control limit. So first one, so y-axis will be C, x-axis is sample number. So x-axis is sample number and y-axis is C, the number of defects. We are going to put defects here. So let us take first one. First one is 3. So first sample 3. 3 means it comes here. Second sample is 8. Where is 8? 8 will go here. This is 8. Second sample 8. So third sample is 3. Again, third sample is 3 here. So this is the problem here with this. Okay. So the fourth sample, as you see here, the fourth sample 3 is, third sample is 3. Fourth sample, this is fourth sample 4. 4 comes here. Fourth sample. Fifth sample is 6. 6 somewhere here. 6. 6. Then 5. This is 6. 5 0 1 2 4. So you can plot like that. 5 0. One of them is 0. 0 is sixth one. It comes here. So finally, when you join, you need to join all of them like this. Okay. So and afterwards 0. Then next is 1. Then 2 here. So you can join all of them. And 4. 4 is somewhere here. This is 4. 4 is somewhere here. So what is the interpretation? All values are within upper and lower control limit. Hence the process is under control. That is our final observations. Is that clear? So all are within the limit. Then the process will be under control. Clear? C chart is a very simple chart. It's not that difficult.
Yes, clear, doctor.
Yeah, any doubts you can ask. Just a minute. Yeah, where it is moving? Yeah, okay. Okay. No problem. I will take it. Oh, the number, in the file. Actually, you have put experiment 5. It is 3. 3. Yeah, 3 consists of several parts, right? Or the number, it is not required, Muhammad. Only the name is required. Really, huh? So you'll correct it and say that. Okay, thank you. Hello. Yeah, any doubts?
No, doctor, thank you.
It's clear.
No, doctor.
Yes. So I think we will stop for today. We will continue tomorrow. Okay.
Okay, doctor. You come back to solution, doctor. 1 minute.
Oh, okay. Yes. The solutions are deleted here because I have written, but in the record it will be there. In the record it will be there. Just watch the record. Any doubt you can ask me tomorrow. Okay.
Okay, doctor. Thank you.
Okay. Thank you very much.